Okay, so for section 1.5, we have applications of quadratic equations. So we're going to look at some real life kind of situations where you would need to solve a quadratic equation. So a trough at the end of a gutter spout is meant to direct water away from the house. The homeowner makes the trough from a rectangular piece of aluminum that is 20 inches long and 12 inches wide. He makes a fold along the two long sides, a distance of X inches away from the edge. If he wants the trough to hold 360 cubic inches of water, how far from the edge should he make the fold? So basically what it's saying is he has this rectangular piece of aluminum. He's going to fold up the edges to create a gutter so that water can flow from the water spout away from the house. And so he's folding it up and it looks like this now. He's folded it up X inches away from the edge to create this ridge to keep the water in as it flows away from the house. And so it started out being 12 inches wide, but since he has folded it up X on one side and X on the other side, X inches, now the width of the gutter is just 12 minus 2X, one on one side and one on the other side, and it's still 20 inches long. But now you have something that can hold water. It is now a trough that can allow flowing water to be held in until it gets away from the house. So we want it so that the water can fill all the way up to be 360 cubic inches of water without spilling over the sides. So how high do we need to make those sides? What is the value that X needs to be so that it will hold 360 cubic inches of water? And that is just volume. Volume of a three-dimensional solid like this is equal to length times width times height. So the length is 20 inches. The width is 12 minus 2x. And the height is x. And we want that to equal 360 cubic inches. We've got 20x times 12 minus 2x is equal to 360. I would go ahead and divide both sides by 20, just noticing that you have this factor of 20 over here, and this is a factor, there's a factor of 20 on the right also. Just to make the problem easier, if you notice something like that, just go ahead and do it. Dividing both sides by 20 will save you time on this problem. So when you do that, your left side is just going to be 12x minus 2x squared. And then on the right side, you're going to have 18. So we have a quadratic equation. We want to get everything on one side. I'm going to move everything to the right side of the equation. So I'll have 0 on the left. And on the right, I'll have 2x squared minus 12x plus 18. So just to make it look nice, I'll just write it in the normal way with the ax squared plus bx plus c on the left and the 0 on the right. I could divide by 2, and I would just have x squared minus 6x plus 9 equals 0. And actually, there's no need to use the quadratic formula. You can see immediately that this is factorable. All it is x minus 3 quantity squared equals 0, which means that the solution is just x equals 3. So 3 inches is how far from the side you should fold it to get it to hold that much water. So don't immediately jump into the quadratic formula. A lot of the time, it's just a lot quicker to factor. Okay, a window is in the shape of a rectangle with an adjacent right triangle above. The length of one length of the right triangle is 2 feet less than the length of the hypotenuse. The length of the other leg is 1 foot less than the length of the hypotenuse. Find the lengths of the sides. All right, so we know that that's a right triangle, which means that it is going to follow the Pythagorean theorem. So we can use that fact to write an equation so we can solve for x. So the sum of the squares of the legs is equal to the square of the hypotenuse. A squared plus b squared equals c squared. That is a right triangle. It holds to the Pythagorean theorem. So now I just need to multiply all this out. X squared minus 2x plus 1 plus x squared minus 4x plus 4 is equal to x squared. So I just I want to get this the way a quadratic equation needs to be so that it can be solved. First thing I can do is cancel this x squared and that x squared. And all I'm left with on the left side now will be x squared minus 6x plus 5 is equal to 0. This is also very easy to factor. No need for the quadratic formula here. We've got x, we've got x, we've got 5, we've got 1, minus, minus. So x minus 5 times x minus 1 equals 0. That means that one of those things has to be 0. So either x minus 5 is 0 or x minus 1 is 0, according to the zero factor theorem. So x could be 5 or x could be 1. If x is 1, that means this side of the triangle has a negative length and this side of the triangle is 0. That is not a triangle. So definitely not x equals 1. But x can be 5. And if x is 5, this triangle has a hypotenuse of 5. And this leg would be 3. And this leg would be 4. And the 3, 4, 5 triangle is a right triangle. So we know that the lengths of the sides are 3, 4, and 5 feet. Okay, if an object has an initial vertical position of s sub 0 and an initial velocity of v sub 0 straight upward or downward, then the vertical position s of the object is given by this equation, s equals negative 1/2 gt squared plus v sub 0t plus s sub 0. This is the equation that models vertical motion. When you throw something up in the air or when you drop something from the top of a hill or a building, the object will travel in a certain way and it can be modeled by this equation. Like I said, that is where g is your acceleration due to gravity, which is 32 feet per second squared on Earth, or 9.8 meters per second squared. Or sometimes you'll hear it said 32 feet per second, or 9.8 meters per second per second. That's always going to be the same if you're on Earth. And then t is the time of travel. How long has that object been in the air since you threw it or dropped it? V sub 0 is the initial velocity of the object, how fast you threw it at or dropped it at. And s sub 0 is where you dropped it from or threw it from, how high above the ground. And then s is, like I said, the position of the object at time t. So suppose that a child tosses a ball straight upward from a height of 1.5 feet with an initial velocity of 48 feet per second. The initial height, s sub 0, is right there, 1.5 feet, so 1.5. The initial velocity they gave us is 48 feet per second. The acceleration due to gravity never changes. It is 32 feet per second squared, so 32 because we're talking about feet. If we're using feet in our problem, we do 32. If we're using meters, we use 9.8. The vertical position of the ball is expressed by this equation. That's what S is. It's the vertical position of the ball at time t. So that is going to be S equals negative 1/2 times 32 feet per second squared, t squared, plus v sub 0 t. V sub 0 was 48, plus s sub 0, which was 1.5. And then we'd want to simplify that to negative 16t squared plus 48t plus 1.5. That would be the position of that object, that ball, at any time t. You could use that equation to find out how high above the ground the ball is after 1 second or half a second or anything. If you plug in that value for t, it will give you that information. Okay, so this time we have a toy rocket that shot straight upward from a launch pad 1 meter above ground level with an initial velocity of 24 meters per second. Part A, write a model to express the height of the rocket S in meters above ground level. So that's what we're going to do first, is use the equation. S equals negative 1/2 gt squared plus v sub 0t plus s sub 0. And so we're going to fill in the information they gave us. So negative 1/2 g, this time we have to put 9.8 meters per second squared because it's meters. This problem has meters, not feet. So 9.8 for g. And then t squared. V sub 0, our initial velocity is 24. so 24t, plus our initial position is this launch pad that's 1 meter above the ground. So that's a positive 1 for s sub 0. Negative 4.9 t squared plus 24t plus 1. So that is the position of the object at time t. Part B says, find the times at which the rocket is at a height of 20 meters. So we want to know, when is the position of this rocket 20 meters above the ground? That's S. So it's a quadratic equation, which means we need to get everything on one side. And in this case, we'll want to use the quadratic formula. So we'd have 4.9 t squared minus 24t, and then plus 19 equals 0. If we plug all that into the quadratic formula, we're going to have negative b, so 24, plus or minus the square root of b squared, so 24 squared minus 4ac all over 2a. So we're going to punch this into the calculator this time. We're not going to give an exact answer for this. We don't want to leave it in a form that has square roots in it and stuff. We're just going to punch this in to get an approximation of how many seconds after liftoff this rocket reaches 20 meters. And it could happen twice. It could pass through 20 meters on its way up and again on its way down. So this is a quadratic equation. It could have two solutions. So I want to show you how to do this with the calculator because I want to make sure that you know how to punch this in all at once instead of punching it in little by little and approximating and chopping off decimal points. You don't want to do that. So just in case you're not all that comfortable with it, let's see how we would do it. The first thing you would want to do is punch in all this stuff that's inside the radical. So you would hit 24 and then you would square it, hit the x squared key. And now you're going to subtract 4 times 4.9 times 19. You can punch that right in. So you hit subtract, and then you hit 4 times 4.9 times 19. You're allowed to do that without any parentheses or anything because your calculator knows that multiplication comes before subtraction. So once you hit the equal sign now, it's going to do that subtraction, and you'll have exactly what is under the radical inside the square root. So that's this number. Now we're going to hit the square root to make it take the square root. All right, so that's what that is. Now we're going to add 24. We're going to do the plus answer first. So it's 24 plus this stuff, 24 minus this stuff. We're going to do the plus first. So I'm going to add the 24, and then I'm going to hit equals to equal out the whole numerator of this fraction. Now I'm going to divide by 2 times 4.9. I could just hit divide 9.8 because I know that's what that is. But if I don't do that, I'm going to have to use some parentheses here so the calculator knows what's in the denominator. So I'm going to hit divided by, and now I'm going to hit the left parenthesis, and I'm going to do the operations that are involved in the denominator. So 2 times 4.9, so that's everything that happens in the denominator, and now I'm going to close the parentheses, and that's what's in the denominator. And now all I have to do is hit equals, and it will do the division that I punched in a minute ago. So this is the value, one value in seconds of when this rocket was 20 meters above the ground at about 3.9 seconds that it was above the ground, 20 meters above the ground at that time. Now there's another solution for when you have 24 minus that stuff. So we need to go back and do that. So let's grab the calculator again. And this time we're going to do the same thing. We're going to punch in the stuff that's inside the radical first. So I'm going to hit 24, and then I'm going to square it. And then I'm going to hit minus 4 times 4.9 times 19. And then I'm going to hit equals. That's the stuff inside the square root. And I'm going to hit the square root key to take the square root of that. And now I want to subtract that from 24 because I want to do 24 minus that. The way I'm going to do that is I'm going to change this number to a negative so that I can add it to 24, and it's the same as subtracting it from 24. So to change this positive number to a negative number, I'm going to come down to this little key right here at the bottom that has a plus and a minus with little arrows around it, and that will make it negative. Now I can add that to 24, so plus 24. Hit equals, and that gives me the whole numerator. Now I'm going to divide that by the denominator. So divided by, and I know it's 9.8, so I'm just going to go ahead and hit 9.8 instead of having to do that 2 times 4.9 again. And then I'm going to hit equals, and this gives me about 1 second. I'll just go ahead and put 0.99 seconds. So those are the 2 times at which this rocket is 20 meters above the ground. Part C wants to know at what times will it be 40 meters above the ground. So it's the same equation, except that now it equals 40. So writing the equation out and then getting everything on one side of the equation again, we would have 4.9 t squared minus 24t plus 39 equals 0. So we need to put that into the quadratic formula again. And so now I'm going to punch that into the calculator again. I'm going to do the stuff inside the radical first. So 24, square it, and then minus 4 times 4.9 times 39, hit equals, and it's negative. It has to be a real number because this is supposed to be seconds. So it cannot be imaginary. It cannot be a complex number. And so that just tells me that this rocket doesn't reach 40 feet. This rocket never gets to 40 feet.